So thanks for staying, everyone. I know there's a number of other excellent talks going on this morning. So this talk's going to be about our transition at ShopKeep from monolithic architecture to microservices and how we failed at it hard. So just before we start, who am I? I'm Paddy Carey. I'm a lead engineer at ShopKeep. I do meetup stuff sometimes, and I'm Paddy Carey everywhere that matters. Twitter, GitHub, whatever, you can find me there. So I'm going to talk to you today about microservices. People love to talk about microservices. They're everywhere. The benefits of a microservice architecture to a growing organization have been discussed by many, many people at many conferences. There are hundreds, if not thousands, of books about it. You can see people like Martin Fowler or Sam Newman talk about this at length, read their blogs, they're really interesting. And as an industry, we're really, really good at talking about the gains in agility and productivity and reliability, all the abilities that such an architecture can provide. The problem is that really few organizations get this right. Certainly not the first time, and certainly not without some serious pain along the way. So I mentioned I'm a lead engineer at ShopKeep, and at ShopKeep we've been through this transition, not once, but 3 times. We've tried and failed to break our monolith apart and move towards the wonderful world of microservices. And this talk is just about that journey, about that failure, and about how we got out of it in the end. I'm going to explore the transitions that we made, the reasons why, and the bad decisions, the silly mistakes. And it's not hopeless though. There is some light at the end of the tunnel, and there's hope for microservices for all of us. So it's worth defining a few terms before we go much further. So what is a monolith? Typically, and I'll explain some exceptions later, a monolith is a large single code base, typically in a single language. And it's typically a single application that combines most or all of a business functionality. So what are the benefits of a monolithic architecture? You get really fast iteration cycles, it's easy to change. Everything's in one place, all your code, most of your libraries. And sharing code and not repeating yourself is really easy. Change management gets a little bit easier. And operations are fundamentally simpler. You only have one thing to deploy, one thing to manage in production, just your monolith. It's not all rosy though. Monoliths have problems. So as your team grows, as your code base grows, you're going to get engineers stepping on each other's toes. Your cycle times will increase as your code base grows and your tests take longer to run, and you have more developers trying to do more work at the same time. It gets harder and harder to stay on top of technical debt as you go along. And without discipline and care, it's really easy to slowly build a large spaghetti-like mess, and I'm sure many of you have been in that situation with large legacy code bases. So what is a microservice? If you ask 20 different people, you'll get 20 different definitions of what a microservice is. And it's really a whole talk on its own to try and distill that down to one canonical definition, so I'm not going to try to. So for the purposes of this talk, when I'm talking about microservices, I'm really just referring to the practice of breaking apart a large application or suite of them into smaller, logically separate components that run independently. No more, no less, and there are plenty of good talks about microservices if you want to learn more about those specifically. So let's start our journey. In the beginning, there was Rails, and it was good. Everything was fine. We had a small team, a Rails code base that was growing fast. It was changing fast. We were adding features. We were improving it. And it all worked great. One of the things that you'll hear often in talks about microservices is that you should always build a monolith first. Never go straight to microservices. Monoliths are fundamentally easier to build, fundamentally easier to reason about, and to manage in production. So you should always, always, always start with a monolith. After a while, our code base grows, our user base grows, the size of our database grows, and that's fine. Rails goes a long way. You can scale up, you can add more CPUs, more RAM, faster networks. All of this works, and it's really easy to do. You just make the number bigger in the Amazon dashboard, and your website goes faster. And that's going to take you a long way. You don't need to consider things like microservices or large-scale refactors for a long time. You can get by with surprisingly little action. Just make the number bigger. You can also scale out. So you can just run more copies of your monolith, scale horizontally. You can run segregated workloads. So typically in Rails land, people use Sidekick to do asynchronous processing. But it's going to share the same code base with your Rails application. So it's the same code base, it's just a different entry point, and you can scale those segregated workloads separately as you need, but you've still got a monolithic code base. You could have 2 web servers and 10 worker nodes, and that's fine. Rails will happily do that for you. So our monolith grew with our engineering team, and like I said, you can go really far with that. I'm not sure if you're aware, but Facebook is mostly a monolithic code base, and it's pretty huge. Facebook's a reasonably big website out here, and so it just proves that with the right discipline, with the right care, you can scale a monolith to Facebook scale. It's doable. It's probably not the easiest thing in the world, but you can do it with enough care and attention. Eventually though, cracks start to appear at the seam. So code bases get harder to manage as they grow. You have more modules, more APIs, more engineers making more changes, especially in a dynamic language like Ruby, where the compiler isn't there to catch your silly mistakes, and I make a lot of silly mistakes. You rely on the discipline of engineers to write tests and diligently review the code of others before it ships. As the team grows, it gets harder and harder to maintain this discipline. People's coding styles change over time, preferences change over time, the tools that you need to use change over time. Some things become unmaintained, you have to replace other things. You have legacy clients in the field that you can't deprecate. Legacy code bases have many issues. So at some point, you realize you're treading water, you're just about paying down your technical debt, you're just about managing the scale for your current workload, and you realize that something has to give, something has to change. So as we grew, as our code base grew, as our customer base grew, our code base was clearly reaching its limits, but so did our database, so did our tools. We originally ran a large MySQL instance. It was really struggling. So we transitioned to Postgres, and that kept us afloat for a while. It was fine. We still run that Postgres instance today, and it handles most of our workload, and that's okay. It works great. But there's only so far you can go with particular data stores. So we use Amazon RDS at ShopKeep, and we're on the largest instance that they provide. So we know where to go. We can't go up. We have to scale out. And it's at this point that you realize that something has to give, something has to change, and it's going to have to change pretty fast. So the competing needs of our growing customer base were taking their toll. We really have 2 distinct areas at ShopKeep that our app is responsible for. That's configuration and management, so things like adding inventory, managing employees, setting the names of the stuff in your shop, and reporting and analytics on the transactions that our merchants carry out. So the very different use cases with very different requirements, and they're often competing in our monolith for the same resources, and they're interfering with each other in detrimental ways. If I run a really long report query, that might lock a table, that might lock a couple rows that I need to update when I'm doing the configuration management. On the bright side, it presents what looks like a really obvious seam to start breaking up our application. We have configuration management over here, and we have reporting and analytics over here. So it seems like a really obvious break that we can make in the middle. So our first attempt to do so, we called it Hercules. I wasn't here when it was named. I don't know why. Does anyone know? No, I'm getting blank stares. So we had some goals with Hercules. We wanted to break out reporting functionality into a new standalone service, something that could take the load off our main Rails application. We wanted to use the tools that we already know, so that's Rails and Sidekick. And we wanted to build something scalable that will allow us to grow with our customer base for the next X number of years. And so some of the decisions we made, I mentioned we have Rails and Sidekick, and we already used EC2 and Capistrano to deploy, so that's just how Hercules worked as well. We didn't want to change that. We already knew Postgres, and so Amazon Redshift was a no-brainer. It's a large data warehouse operated for you by Amazon, a database as a service, and it works okay. Hercules lives behind our existing monolith, so when a user wants to get a report, they hit our existing application, the endpoints don't change, and the Rails application just hits Hercules. So it should be, in theory, invisible to callers and our clients. So what are the lessons that we can learn from our first attempt? I haven't explained why it didn't go well yet, but we'll hopefully understand as we go through. So getting your ducks in a row, it's really important that when you start this, that if you have a poorly structured monolith, do you really believe that you can write a well-structured set of microservices? I don't. So unless your house is already in order, unless your monolith is already well-factored and well-structured, you're going to have a hard time. You're going to have a really bad time. And that's the position that we were in. Some of our monolith was good. Some of it was recent and new and shiny. Some of it was really old and horrible, and nobody wanted to touch it, and nobody was going to touch it. There wasn't a business need to. So we certainly weren't ready for this. Our systems were still somewhat coupled. They knew too much about each other. And we spent time working around the fact that Redshift isn't really designed for the use case of customer reporting, customer analytics. It's a data warehouse. It's designed for large, slow queries, and that's not our usage pattern. Our usage pattern is lots of small queries for transactions over a couple of days, couple of months. Redshift doesn't cope so well with that, with large query volume. But when all you have is a hammer, every problem looks like a nail. We had Rails Sidekick, and we knew Postgres. It seemed obvious at the time. Clippy puts this best, I think. I see you have a poorly structured monolith. Would you like me to convert it into a poorly structured set of microservices? You need to be prepared to fail. It's really important to be able to see when a project isn't working out and be prepared to call it. The longer you wait, the harder it's going to be to rip that plaster off. As soon as we realized that Hercules wasn't working, we should have just stopped. We should have called it. We should have reevaluated our decisions. We didn't do that. We spent way too long trying to dig ourselves out of a hole and out of some of the bad decisions that we made, when we could have been reevaluating those decisions and putting ourselves on a better track. So, back to the drawing board. Hercules wasn't working out. Our first attempt chugged along for a while. I mean, it worked okay. It was powering our merchants' reports, but it wasn't great. It was clear it wasn't scaling the way we needed, and it was more difficult to manage than we had intended. When this happens, it's really important, actually it's crucial that you sit down with your team and thoroughly and really dispassionately hold a retrospective on your decisions. It's not about blame, it's not about finding out who made the wrong decision. It's about understanding that the wrong decision was made and that if you work together, you can fix it. So we weren't ready. We didn't get this part right. That would become clear over time. We didn't correctly identify the problems with our initial attempt, and it put us at a disadvantage right from the start. So even when we moved on to our second attempt, we didn't properly know what went wrong with our first. And that's a really hard thing to admit, that your problems are, that you don't understand your own problems. But it's clear that we didn't. So, attempt number 2, platform. It's such a terrible generic name. I'm sure almost everybody working here has a platform at their work. It makes no sense. And platform itself made no sense. So, we have some goals for the platform project, and you'll notice they're almost identical to the Hercules project. Our goals here haven't changed. The only thing that's changed is that we've decided we're now willing to try out other tools. We're willing to try out what we think are the best-in-class tools to build something scalable. And for us at the time, that was a lot of new and shiny technologies. It was a lot of, I like to imagine the developers at that time were a bit like magpies, just lots of shiny things floating around. Oh, we'll have that. Oh, we'll have that. So we had Docker, we had Deis at the time. We were using tools like Cassandra and Kinesis and Postgres, Elasticsearch. We used Go. We used protocol buffers. All shiny, all new, great. One of the big changes we made here was that we had a brand new set of client-facing APIs. So we did expose new APIs to our clients, but because we have so many legacy clients, I didn't explain we build POS software, so till systems, and we have merchants in stores that just don't want to upgrade their systems. You don't want to upgrade your till system if it's working okay. So we have old clients that we have to support in the field, and there's not much we can do about that. So we have to support old APIs, and those old APIs are still going to be available even after we expose our new ones. We still had a really poorly structured monolith. We still didn't fully understand the complex seams between the parts of our large code base. We didn't understand the interaction between the configuration management and the reporting systems. Not really, not fully. And if you don't have your systems in order, then you're doomed to repeat the mistakes of your monolith. only with the addition of more unreliable networks in your critical path. That's really the difference. Monolith, if your monolith is in a bad state, your microservices are going to be in a bad state too. So don't throw the baby out with the bathwater. It's a really important lesson we learned on our second attempt at this. Our monolith still mostly worked for most of the things it was built for. It still performed reasonably well, even if it was showing signs of fatigue in places. We didn't need to replace as much as we did. Attempting to replace so much in a short time with so many new technologies with a mostly new team was always going to be really difficult. We tried to replace reporting, authentication, API gateway, transaction storage, transaction search. There was another one in there too. But we tried to replace everything at once, and that wasn't going to work. It was a really big bang change, and big bang style changes or rewrites almost never work. They almost never end well. So this is a really important one, and one we fell victim to pretty early. Beware of a distributed monolith. It's really easy to slide into, you think you're building microservices, but actually what you've built is a distributed monolith. So in a monolithic code base, you'll often find years of common tooling, common patterns, common frameworks, a collection of common functionality that's been layered up over time to provide support for engineers that are working in the code base. As you begin to break it apart, it's tempting to think that using such a layered approach or reusing it in a microservice architecture is what you need. You can provide a solid base of functionality and give a solid foundation on which all your future services can be built. But when using a layered approach, it's really easy to couple everything you build by relying on too much shared code and knowledge between the systems. If you get your boundaries or your seams between the applications right, you won't need to. You won't need to share all that code and all that knowledge. Keep your context independent. A really nice test for this is if you can't deploy your microservices in isolation, then you might have a distributed monolith. You might. If you make a change to one and have to deploy 3 different things, that's a really bad smell. So it's not to say that common code or functionality is a bad thing, just that you need to be careful to avoid the accidental coupling. When you break apart your monolith in vertical slices rather than layers, so whole business features really, it allows a single team to own that whole piece of functionality from the top to the bottom. It gives them the freedom to implement it in a way that makes sense for that team, makes sense for that feature. Teams, when they build properly isolated features and own as much of the stack as possible, it helps decouple one service from another, just through the fact that people are making different decisions in different areas for different reasons. So on the topic of distributed monoliths, this is a real diagram from our platform project. That's our Go code base and the dependencies between our services. There are cycles in there. It's just horrible. Nobody wants to come into work every day and work on that. That's just not nice. We made one change over here and we had to deploy all these things. We had a distributed monolith. There's no two ways about it. So this is somewhat related to the earlier point. Find the smallest part of your system that can be broken out with maximum return on your effort and do only that. We didn't need to do authentication. We didn't need to build an API gateway at that time. We didn't need to do transaction storage. All we really wanted was reporting. But we decided to do everything at once because we thought, oh, well, we're changing this one thing, it'll be easier to change everything else. A really nice thing that one of my colleagues keeps repeating to me over and over and over again is make it work, make it right, make it fast. If you do things in that order, it just helps ground your expectations and helps you to make good decisions and build the right thing at the right time. Don't make big sweeping changes like this in isolation. At ShopKeep, we had a growing engineering team at the time of platform, tens of engineers working in our existing backend, adding features for our merchants and generally just working to expand our product offering. So meanwhile, a small team of 4 to 6 developers were responsible for the entire platform project, which was intended to replace most of our existing code. That didn't work too well. It never works well when you're working in a silo and throwing the finished product over the wall. There's always going to be resistance to that. When people don't have a say in what's being built and what's being designed, then there's always going to be problems. There's always going to be some problem when those two worlds come together. So this is an obvious one, but if you can't see what's going on in your system, you can't monitor, you can't debug it, you can't maintain it in production. That's a problem. When you have a monolith, it's easy. You just drop in the New Relic agent, or you just use Datadog or whatever monitoring tools you use, and it's fine. It just works. Everything's there. It does it all for you. But when you're moving towards microservices, you need to put in the extra effort to make sure that you can monitor and maintain your systems. So if it's not monitored, it's not finished. If it's not debuggable, it's not finished. If it doesn't have appropriate alerting, it's not finished. And those are really, really crucial in a microservice architecture, because if one of your 100 services fails, you want to know about it if it needs attention. And we didn't have that. We failed here. We wrote a custom plugin for New Relic that allowed us to monitor request times, and that was it. That was the only information we had. We had logs and request times, and that was just terrible. It didn't allow us to adequately operate the system at the scale we needed. So this might be a bit of a controversial one, but shared schemas can be more of a hindrance than a help. Having a shared understanding of the data flowing through your system, it's incredibly useful, but having a set of shared schemas can be a problem, or can be an issue at times. In our case, it certainly was. So we decided to use protocol buffers. For some background, it's a typed binary message format to share data between systems. And lots of large companies like Google use protobufs really successfully, but we made a crucial mistake. We relied on code generation in a central location to use our protobufs and to generate libraries that we could use our protobufs with. That meant that anytime we updated our protocol buffer definition centrally, we had to then eventually deploy it out to all of our services, which was a real pain. You know, when you've got 20 services and you have to deploy 20 times just to make a change that doesn't even matter to service X, that's a pain. That might be a sign that you've got a distributed monolith. So, lesson 10, use a real API gateway. So one of the biggest mistakes we made in both these attempts to break apart a monolith was to put the new services behind our existing Rails app. It seemed sensible at the time. It allowed us to maintain our existing APIs and the facade that we presented to clients, but it just didn't work out that way. There's the reason that nobody uses Ruby or Rails as a reverse proxy, because it's awful at it. Same goes for Python or WSGI servers. We find ourselves often being taken down completely by services that were behind our monolith going down or getting slow. We were just tying up resources with requests going to microservices through a substandard proxy, and that was taking everything down. Failures of systems that I didn't know existed were taking down our application, and that's a problem. So one of the most important things we realized is the importance of agreeing failure modes with your product team. So one of the supposed benefits of a microservice architecture is the ability to fail gracefully when some part of your system fails. But without proper care and planning, it's really easy to miss this, and we certainly missed it the first couple times. So you need to be able to answer questions like, what happens if our authentication servers go down? Can already authenticated clients still connect? Maybe, maybe not. What happens if our data pipeline goes down? Can we still generate reports on the data that's already there? You need to be able to answer these questions when someone asks you what happens when part X of my system fails. So ultimately, the platform project failed. We eventually got to a point where it just wasn't tenable anymore. It wasn't working. It was clear it wasn't working. So how did we find ourselves back here? We gained a lot of experience. We learned a lot from the project. And at this stage, our monolith is still running. We're still running the Rails app. Hercules is still running. We're still running the Rails app there. Platform is still running. So we have our monolith, we have Hercules, we have the whole set of new Go services over here. We're arguably in a worse place than we were when we started. So let's take a step back. We're sitting at the end of a failed project, wondering where to go. And this time the retrospective is even more important. What did we miss the first time? How did we get it so wrong the second time? This time was different. We deliberated, we analyzed, we prototyped, we changed our expectations. If at first you don't succeed, try and try again. So the third and final attempt is where we are now. We have Rogue. It's the current application I work on most days in work. And the goals have changed slightly. We still want to break out a reporting functionality and do a new service that can consolidate our previous attempts. We want to get rid of Hercules. We want to get rid of platform. We want to use the best tools or the ones we're most comfortable with. Crucially, the main difference here, we want to initially replace only our existing reports. We don't want to build new ones. We don't want to have a whole bunch of functionality that's brand new to our customers. We want to take the bit that's misbehaving and re-implement it, and that's all. That's where the project stops, no more, no less. So in this case, we went a small handful of Python services. The team that was building it, we all knew Python better than we knew Ruby. That was the height of the decision making there. We used a message queue for shuffling data between services asynchronously, and we initially used SNS and SQS for that, but now Kafka. And it was a CQRS type design. We have different paths for writing data into the system than we do for reading data out, which is really helpful because it means one side can go down and the other one stays up. So start small. By deciding to only implement the existing functionality, we can concentrate on getting our architecture right, what we needed right then, not what we might need in the future. Don't try to solve every problem at once. So vertical slicing allows for easier decoupling. So on our third attempt, we had a really clear picture of where the seams in our application were. We were able to properly carve out the vertical slice of functionality we needed. And we re-implemented things like authentication and routing. Like I said, we shouldn't. But we did it for our specific purposes. For reporting. We didn't care about what anyone else needed. We didn't care about what the company needed. We just implemented what we needed. And we just explicitly didn't try and solve them for the rest of the company. That was never going to work. And it was clear from our previous attempts that was never going to work. Sometimes plain and boring works best. We chose Python and Elasticsearch. At that point, neither of them were particularly new and cool, but they work for us and they work well. So it was clear by the third attempt we didn't have a great understanding of the constraints and the failure modes of our system. So we worked a lot with product to decide when is our system allowed to go down, under what circumstances is our data allowed to be late, what are our SLAs, what are our targets for freshness and response time, and we could then measure ourselves against those as we built. Previous attempts we just built and we realized they were a failure later, but we had actual measurable objectives this time that we could measure against. Set precedent by example, not by decree. So this is really just the first couple of times we made decisions and then tried to impose them on the services. This time we let the services grow organically, and those became precedent rather than being imposed by an architect or a senior engineer. Everything should be replaceable, even you. So one of the hardest lessons we learned was that it was really, really difficult to replace some parts of platform or parts of Hercules. And the new system, we made sure that we could replace anything. We started out with SQS, and within 6 months, we had moved to Kafka, and it wasn't a big deal. It just worked. So resilience is key, and this is a whole topic on its own, but services will fail, networks will go down, gremlins will screw up your shit. You need to be prepared for it. You'll need to consider problems like circuit breakers, kill switches, timeouts, redundancy and sharding, retries and idempotency. It's a huge topic, and it's something you really need to think about when you're doing microservices, but it's a whole other talk on its own. Automate everything. If you have humans in the loop, stuff's going to go wrong. Stuff's going to get mistyped. Someone's going to fat finger their mouse and accidentally deploy the wrong thing to production. So use CI, automate your deployments, your tests, automate your monitoring, and automate simple remediation. So if a server dies, just bring it back up automatically. You get it right once, and the rest comes easy. So we built Rogue, it worked well, and other teams were able to take that example and build new services following the Rogue model, rather than following a model that we had decided before Rogue happened. So be patient. If you do good work and don't attempt to solve everybody's problems, you'll end up in a better place. So in conclusion, microservices are hard, really, really hard, and I don't think people realize that. You'll probably get it wrong the first time, and that's okay, so long as you learn from it. In fact, unless you make these mistakes yourself, you're unlikely to appreciate the subtlety and the pain of some of the decisions that you're making. I know I certainly didn't until I crashed and burned. Don't be afraid of failure, embrace it, iterate where you need to, that's okay, and you can always start over, always. Thank you.
Thanks very much, Paddy, for that. Does anyone get any questions?
Will the presentation be online?
It will.
I actually do have a question for you. Sorry. Obviously, that was hugely interesting, and as a developer who's looked at microservices before, it's a great insight to what can go wrong. Is there any kind of resources online that you'd recommend for people to kind of look at to kind of get their head around the scope of what can go wrong?
There's some great books. Google have a SRE book, the Site Reliability Engineering book, and it's available free online. It's about how they build and operate their services at scale.
Excellent. Okay, thanks very much. Thanks very much, Paddy Carey. A round of applause again, please.